Okay, welcome to this first video of our unit on probability. This is section 8.5 and an intro to probability, and it starts off by just talking about some very basic ideas. Then I had to go through, and then I'll go through an example from the homework sections from the exercises. So the first idea they go through involves two concepts I want to make sure you're clear on. One of them is random outcomes. And equally likely outcomes. Okay. So random outcomes means you have different things that can happen, and they're selected according to some random process, meaning it's hard to predict exactly what's going to happen. So the typical examples of random processes are flipping a coin, rolling a die, picking a number from a hat, something like that, where the outcomes are determined by chance, not by some deliberate design. Now, when they're equally likely outcomes, it's a pretty simple concept too. If you have random outcomes, each one seems equally likely when they're all equal in terms of how likely it is to be chosen. So when you flip a coin, it's just as likely to come up heads as tails. If you roll a die, as long as it's fair, all the sides are the same area, it's not weighted or anything, then each of the sides could come up equally often if you kept doing it over and over again. So this is a concept that's at work behind all sorts of probability questions. And it might not apply if your probability question doesn't have equally likely outcomes, or if they're not randomly chosen. So keep your attention on that when you apply the concepts from this section to everyday life. Okay, now one thing they go through here that's a very basic idea, that when these things apply, then we can talk about the probability of an event. All right, well, this is an event. And what's an event? It's a set of outcomes. Okay, just like from what we did in set theory. So that's why we had to do set theory first, because we're talking about sets. All right, a set of outcomes. And the universal set is the set of all possible outcomes. All right, all possible outcomes is the universal set. Okay, so if I have some subset of the universal set, then I can talk about the probability of that event occurring, meaning an outcome in that set occurring, in terms of the cardinal numbers of the sets. So the definition of probability here is it's the cardinal number of the set divided by the cardinal number of the universal set. So basically we're counting the number of elements in a set and dividing it by the total number of outcomes. And it seems pretty clear, this is just like if you're dealing with cards and dice or roulette or any casino game, that you randomly pick one of them. The chances of that event happening are the number of ways it can happen divided by the number of ways anything can happen. So this is the basic definition. We're always going to be dividing one number by another. Since we're always dividing one number by another, there are a couple of things that come out of that. Here's the basic idea from basic fundamental probabilities. So all probabilities then are less than or equal to 1 and greater than or equal to 0. If you look at the number of outcomes in an event and there aren't any, then it's the empty set, and that has a cardinal number of 0. If you look at the number of outcomes in the set and it's all of them, and you divide by that, you're going to have 1, same number on the top and the bottom, and that means that event is bound to happen because all of the outcomes are included in it. So every probability value we get is a number divided by another. It will always be a fraction then, always between 1 and 0. If it's 1, it's certain to happen, and if it's 0, it's impossible that it would happen. So we're going to have fractions and decimals, and we're never going to have any negative numbers. We're never going to have any numbers greater than 1. So we deal with a lot of fractions and decimals in probability. Okay. Now one other formula is gone through in this section. And let me just write it on the board, and then we'll talk about what's going on with it, okay? It's from set theory, and what it says is that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B, okay? And this is basically just from the whole set theory idea that the union of a set, if I have A and B, the union of this set is I add up all the elements in A and all the elements in B, but when I do that, I've added intersect B twice, so I have to subtract that to get this value. So this is an equation we have in cardinal numbers. This equation is given to you in your formula book that you get to use during the exam. So it's a nice set theory formula. We saw some applications of it in set theory, and now we're going to put them to work in probability. So let me stop this video here, and then we'll go on and we'll look at an example from the homework section.